This video is designed to help students with order of operations. I'm going to use specific examples from the algebra textbook from lesson 1.2. So in order of operations, we have expressions like this one, problem number 17, that has more than one operation, and we have to decide which operation to do first. And mathematicians a long time ago came up with some rules for that, and we remember those rules by an acronym called Pemdas. Pemdas stands for parentheses, so we always do parentheses first, then E for exponents. Multiplication and division are the next step, and you do both of those in the same step. You go from left to right. Those are the same value. And addition and subtraction also have the same value, and you do those from left to right. So we do them in order of things in math that have the most power. So in this particular example, we had 20 minus 2 times 3 to the second power. And as we look at the rules for PEMDAS, or order of operations, we don't have any parentheses. So the next most important step is exponents, 3 to the second power. So we choose that operation to be done first. And what I like my students to do is communicate a pathway through their work. So what we do is we make a bracket underneath it. I call it a bracket thingy-majig. And all it does is it indicates what we chose. So we're going to do 3 to the second power first. 3 to the second power is 9. And then we write the rest of the problem as it was. We don't do any more than one step at a time. So now we have a choice between subtraction and multiplying. And according to PEMDAS, multiplying is more powerful, it has a higher priority than subtraction. So we'll do that next. And 2 times 9 is 18. Bring down the 20. And then we have one step left. So our last step would be subtraction. 20 minus 18 is 2. And so when you evaluate this expression, the value you should get is 2, using the correct order of operations. You will notice also that if you look at the number of operations in the original problem, there's 1, 2, 3, you will have 3 lines of work underneath the problem after you've written it. So here's the original problem. There's 1, 2, 3 lines of work. We write that in what we call vertical form so we can read it and follow the path. We also follow the path through the choices we made according to the order of operations. So here's another example. This one's a little bit more complicated. It has more steps. As we look at this one, the first thing I like to do is count the operations. I see 1, 2, 3. There's a multiplication right here, that's 4, 5, and the exponent makes 6. So I should see 6 lines of work as we choose which operation to do first. So in this case, we do have parentheses. We always do parentheses first. So we will indicate that as such. And then 4 minus 2 is 2, and we keep the parentheses there because we're not really done with it until we do the exponents, so we'll include that little 3 there. We have a 3 out here, and when there's nothing between the 3 and the parentheses, we know that means time, so I'm going to include a little time sign right there. And I'll write the rest of the problem the way it looks. Alright, now we'll do exponents, and I have 2 of them. And the other rule for order of operations is when you have 2 of the same value, the same step, the same priority of operations, you do the leftmost one first, the first one you come to. So out of these 2 exponents, I'm going to choose the leftmost one first. And I only get to do 1 because that tells me that a person knows which step to do first. So 8 squared is 64. I'm going to go ahead and eliminate those parentheses at this time. You can leave them there if you'd like. Okay, so now I still got some exponents to do, so I'll do the rightmost exponent first, or last, and that's 8. So I've eliminated all the exponents. Now I look for multiplication and division, and I do have a multiplication here, so I'll do that next. And now I'm left with adding and subtracting. And since they have both the same value, and they are the last step, we do them from left to right. So I'll do the addition before subtraction, just because it comes first. So that'd be like 110, 116 minus 24. And then the last step would be subtraction. And that should get us an answer of 92. Now I should also mention that we expect students to show their work. It's part of the Common Core state standards about explaining and justifying as part of what we do. The answer is important, but the process is more important. And we do it this way so we can communicate the same way. However, when you're done, you can always check this answer by keying in this expression exactly as it looks on your calculator. Your calculator, scientific calculator, should give you this answer as long as you key it in correctly.